What is?
I like that. Not a treep. All right. Hopefully you guys got the same thing as Nolan. If not, let's walk through it because all of today's lesson is going to be based off of this example. So you want to make sure you have the data in your lists. Lists. That's a weird word to say. So list 1 should be the number of passengers, 2, 3, 4, 5, 6. Maybe if you don't bump into my calculator. And then the probabilities should be in list 2, 0.15, 0.25, 0.35, 0.2, and 0.05. Once you have those in your list, to get the answers that Nolan got, you would hit Stat, go over to Calc, 1-bar stats. List is list 1, frequency list is list 2. Our average or expected value is 3.75, standard deviation 1.0897. Now, like I said, the rest of the lesson today is going to be based off this idea, Pete's Jeep Tours. So did we all actually read it too? No. Will you read it for us, Caleb, since you at least admitted you didn't? Out loud, not in your head.
Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers to find access to a number of passengers on a randomly selected day.
Thank you. All right, so we have a tour trip. I don't know what you would call it. A Jeep tour. Let's say we're in it. It makes me think of Africa. I think you'd be on safari. I don't know. Where do you think this tourist area is, Nolan?
The dunes.
The dunes. That's right. People do.
People do.
They do the dunes. Anywho, moving on. So, today we're going to keep working with our discrete random variables, but we're going to do some transformations to them. So the first transformation is that Pete charges $150 per passenger. So we're going to define the random variable C as the amount Pete collects on a randomly selected day. So if he has 2 passengers, how much money is he going to collect? $300. If he had 3 passengers, how much? And if he had 4 passengers, 5 passengers, and 6 passengers. Thank you, Jillian. So now that you see how much money he would collect based on the number of passengers, I want you guys to please find the expected value of C, so expected value of how much money he collects, and the standard deviation. Jillian, what? Not you. Jillian that I had last year. Bridges? No. And no, she was in my AP stats last year. No, wasn't. Madeline.
Wait, Madeline? The Madeline, Williams?
Yes. Yeah. I thought thought you were gonna ask for a calculator. That's why I was walking over here because I thought you were gonna be like, "Hey, can I borrow a calculator?" And I was gonna be like, "Yeah, here it
No,
is."
I forgot my calculator on my desk or in my car or something.
Yeah, in the textbook, your dog ate that one too.
Yeah, I have it because I have a dog.
Yeah, for sure.
Oh, the
Oh,
Seattle one?
I thought you were talking about like right now.
I have to go to that too. I just
You
have to
know,
go
you
too.
don't have to play soccer.
I want to go. I just had to go there too.
Maybe we might need one at spring break.
You trust Bianca?
We're not.
I will be doing it.
You'll be here. Usually my father-in-law, because he's got 4 acres, takes our dogs. But our dog, our puppy, chewed up one of their case lounges the last time I was home. It's very
On a cushion?
You don't have anything expensive like that in your house, right? Okay, because I was like, if that happens when I dog sit for you, I don't know if I can reimburse you.
to be outside the entire time. Rained on, snowed on, rained. So she got really mad.
She don't remember how to soggy cushion.
No, because our dog chewed on it.
I know, but it gets soggy up over here.
And when they watched our dog, the dog was like 5 months old, and my teacher left the dog outside for 8 hours. It's kind of like, really? And you're gonna believe it. Sorry. They got me on a tangent.
It's about tangent.
Yes. List one. Is that where you have
No, I didn't do my warm up for that. I was still trying to get off.
So then
Oh, is that the answers?
list two.
Oh, I just didn't do
Oh,
that.
that one.
There must be at least, so it's at least 300 just every time. And it's popular, so it's probably at least one.
You know, remember that Raul kid? Remember that Raul kid?
You might have to be there later.
Raul,
So
the 4G kid? Remember that kid? You know? The little... What?
so it's
He was on the team, yeah. Full refresher. He was from Spain, dude. That kid, remember that kid? I just realized I had 4G students here. No, not that, I was saying, I just realized I had 4G students, so it made me think of that. Which one?
Yes.
The Brazilian one?
Between the bar over
Oh, Lydia.
I
Dude,
use X-Bar,
she was here?
but
not going to-
the gear
Oh.
thing, it's Sigma.
No, but give the
just means
Brazilian
it added
girl.
all the X's together.
Well, if it's like a
Is it always one of these buildings?
The junior?
Almost half a day.
I'm not
Yeah, it's the
positive
Brazilian.
on that. So just always
Yeah,
use
look, it's the
X-Bar.
Brazilian.
Alright. Sam came up and put the answers down for us. Our expected value for the amount of money Pete collects is 562.5. Standard deviation 163.45.
I didn't round up, sorry.
That's okay. Anybody want to venture a connection between these answers and our warm-up
it's
answers?
multiplied by 150.
It is multiplied by 150. So the expected value for the number of passengers Pete had from the warm-up was 3.75. If we take that 3.75 and we multiply it by the $150 per passenger, we get our expected value of the amount of money that Pete's going to collect. 3.75 times 150, and we get the 562.5.
Is G.
Same thing for the standard deviation. In the warm-up, Nolan told us the standard deviation for the amount of passengers was 1.0897. If we take that standard deviation and we multiply it by the 150 per passenger, we get the 163.45 like Sam gave us. Everybody good? Can I move up my paper? Alright, so down below, still working with Pete and his Jeep tours. C was the amount of money that Pete collected on a randomly selected day, so I just copied the table down below. Our mean for the amount of money he collected was 562.5. Standard deviation 163.45. It costs Pete $100 per trip to buy the permits, the gas, and a ferry pass. Maybe not in Africa. I don't know what ferry they'd be taking in Africa. The random variable V is going to describe the profit Pete makes on a randomly selected day. How do we find profit from the amount of money that he collected?
Subtract 100 from the...
That's correct.
Yes.
Yeah. So he's got the money he collects. Then we have to subtract the 100 that he would spend no matter how many passengers he has. So 300 minus 100 would be 200 here. 450 minus 100, 350. This would be 5. This would be 650. And this would be 800. You guys are going to find the expected value for his profit and the standard deviation for the profit, please.
He is rolling it.
Well, we expect that Pete will want it cash.
That's true.
It's not.
But it says it's popular.
It
So
does
we
say
could
it's
assume that
popular.
he probably does this like 5 times a week. Because it's a half day thing, so I would assume
Maybe he
probably
does it
would.
twice a day, 5 days.
Twice a day.
Rolling in the cash.
But it is a half a day thing, so
Yeah.
if you expect like a 6 to whatever, unless he's doing different nighttime tours.
You guys should really get in cahoots with Pete and make some money.
Why would, if he has this deal that he's doing already by himself, how could we get into it?
Well, because
What
you
if we
guys
triple
might
it?
have ideas on how to make him more
3
money.
different tours that make the same amount.
Yeah, or
So
if
we
he has
all
more
do
drivers,
this.
he could make more
In
money.
this one business. We start a name brand, essential area, you dig, we have 3 off besides him.
And then we'll get, an MLM value.
Do you see this pyramid scheme?
And then we tell them to do their tours, and they give us a profit. And we'll tell them that eventually we'll give them an upgrade if they get to a certain amount, but they never will.
We got this.
There'll be thousands of tours a day. But we just have to do a tour or whatever, every so often.
Like when you call that big C guys, and they're like, can't figure out how to permit
be on playing soccer right now? Or no?
It's like, hey, watch out
Are you playing soccer now? Or no?
December that like is messing up computers
This is
right now,
the reason
and
to take
And a lot more
if
than
you
that.
updated a Microsoft computer in December, make sure both the files are exactly the same thing. There should be the same amount of storage, the same
But I could play
numbers, the
basketball.
same letters. Everything should be the
But I
same.
could play
But if they're
basketball.
different, then you're at risk for your computer to like shut down. So watch out for it.
4 days off.
School can pay for a new computer for me.
They don't give me
I knew
the
that.
last thing.
Alright, so expected value for Pete's profit 462.5, standard deviation 163.46 or 45. So what is the relationship with the expected profit from the expected value of how much money he collected?
Minus 100.
We took away 100, right? Which is what we did to get our values here. What about for the standard deviation?
It stays the same.
Stays the same. Anybody happen to remember this? We did this in chapter 2, but we focused on dot plots and moving them. The transformations, linear transformations, and we made it much more close together, and then, yeah. So, multiplying affects both your mean and your standard deviation. Subtraction only affects the mean, doesn't affect your standard deviation. And I think that's pretty much what I did on the next page. I took the way the textbook summarized it, and I put it onto your notes for you, and I'm looking for my highlighter. There it is. So, multiplying or dividing by a constant. If we multiply or divide, because dividing really is multiplying by a fraction, we're going to multiply our measures as center. So the mean, which is also known as expected value now. So if they ask you what's going to happen to the expected value, it's going to do the same thing that the mean would do, because they're the same thing, we just have a new name for it. When we multiply or divide, it multiplies the measures as spread, which is the standard deviation. Shape stays the same. If we multiply a variable by a constant, it's going to multiply the variance by b squared, because remember, variance is your standard deviation squared. So it would end up multiplying it by b squared. Then down below, summary of what happens when you add or subtract, because adding and subtracting are the same thing. Subtraction is like adding a negative. So if we add a number, it's going to add that to our measures as center, like the mean. It does not change the measures as spread. Like standard deviation. And then of course shape stays the same still. Shape always stays the same. So we're going to use this idea to do some linear transformations of random variables. Linear, what's the most common form of an equation for a line?
Y goes up. Y goes
y equals mx plus b, right? So that's our like general form of a line. If we were back in algebra, we'd say, oh, this is linear, y equals mx plus b. So when I say linear transformation, it's the same idea. B is being multiplied by x, because if you look back up at the top here, that's what they said. We were multiplying by a number b. So we multiplied b by x. And then we were adding an a. So instead of y equals mx plus b, we have y equals a plus bx. It's just taking a random variable and making it linear. If we do that, the probability distribution of y has the same shape as the original probability distribution. Our expected value would get multiplied and then added the number to, just like it did with Pete's Jeep tours. The standard deviation would only get multiplied by b, and they do say the absolute value of b because we could technically multiply by negative numbers. So now we're going to do some more transformations. Still working with p, but we're going to introduce his sister, right? Siblings. Alright, so we're going to investigate the result of adding and subtracting random variables. X is the number of passengers on a randomly selected trip with P. Y is the number of passengers on a randomly selected trip with Aaron. We're going to define T as X plus Y. And we're going to figure out the mean and variance, standard deviation of T. We're going to use the variance, find the standard deviation. So this is just like from the warm-up. So that was when Nolan came up and gave us our expected number of passengers, which was 3.75. And the standard deviation was 1.0897. We need to find the expected value and standard deviation for Aaron. So Aaron has 2, 3, 4, or 5 passengers, probability of 0.3, 0.4, 0.2, 0.1. I want you guys to find the mean, the expected value, and the standard deviation for Aaron, please. All right, what is the expected number of passengers Aaron has? Thank you, Shania. 3.1, standard deviation of? 943. Questions? Okay. So, how many total passengers can Pete and Aaron expect on a randomly selected day? So, Pete, we used X. Aaron is Y. So, when I say Pete and Aaron, really I'm taking X plus Y. So, we're going to make a few predictions. I want you to take about 30 seconds, talk at your table. What do your table mates and you expect the expected value for Pete and Aaron together? And what do you think the expected standard deviation is going to be? 30 seconds, talk with your neighbors. Maybe there's a bird up there.
It is crazy windy.
The wind is crazy today.
That's pretty great.
All right. Let's start back here. Miranda and Bianca, what do you guys predict the mean to be? 3.85? 6.85? Okay. 6.85. And then what do you predict the standard deviation to be? 2? Okay. Back here, Jillian, Lisa, Ray. What did you guys come up with for your predicted mean? It's just a prediction.
We said so 3.4.
Okay, so you took this plus that and divided by 2. Okay. And what about standard deviation? 1.7. Okay. Emma, Narita, and Nevaeh?
Um, 4.03
Okay.
and 1.57.
Are those like special numbers?
No, that's my prediction.
Okay. All right, Tanner's table.
We agreed with the first one, so 6.85 and 2.
And 2. All right. DJ, Shania, Annika?
We said 6 and 2.
Just 6, not 6.85. Okay. And then you also said 2. And then Grace, Seth, and Cecia.
6.85 and 1.017.
Okay, 6.85 and 1.017.
Yeah.
Okay. All right. So in a minute, we're gonna
Like,
figure
you
out.
ask us.
Oh, I
That's
did
messed up.
forget you guys. I'm sorry.
That's messed up. This is-
Kayla, what did your table come up with? Huh, maybe this is why I didn't call on you
Alright,
guys.
6.85
6.85,
and then 2.0327.
2.0327.
Yes.
All right. I do apologize. I didn't mean to skip you guys. So, in a minute, we will figure out if any of you are right. But first, a couple things we have to talk about. So, the only way that we can determine the probability for any value of t is if x and y are independent random variables. What does it mean to be independent? They're not affected by each other. So,
Kind of are. If one of them does bad, then the other one probably.
well, the way we're going to say that they are independent is we're going to say they're not competitors. We're going to say they're on opposite sides of a country so that Pete's not stealing Aaron's passengers and Aaron isn't stealing Pete's. So then we can assume that they're independent. and that's down here at the bottom. Now, the weird thing about these type of problems is that they often assume independence. Just because we often assume independence does not mean you shouldn't question whether the assumption is reasonable. For this, so that we can actually do the next part and add the two variables together, we're going to say they're independent, because otherwise my whole lesson would be pointless. So we're going to say they're independent. Can I flip? All right, so we're going to fill this in, this table. Then you're going to put it into your calculator so that the calculator does the hard work. So we are defining t as x plus y. X is the number of passengers that Pete has, y is the number of passengers Aaron has, which means there's a lot of different combinations because, excuse me, Pete could have 2 passengers, Aaron could have 2, 3, 4, 5. So 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4 is 6, and 2 plus 5 is 7. And then remember from last chapter, if we have probabilities that are independent, we can multiply them. So the probability Pete had 2 passengers and the probability Aaron has 2 passengers gets multiplied together to give us the probability that together they have 4 passengers. So we're going to fill in the rest of these 2 columns. Mainly you guys are, because you don't need to watch me add and multiply. You know how to do that. For this column, you're going to add these 2 numbers together. For this last column, you're going to multiply those 2 numbers together. I put the numbers up on the board if you want to check with what I have. I could have made a mistake too, so please check. Make sure that we match. I did some of the multiplication in my head, so I might be off a little. Once you have your columns filled in, we're going to put them into our lists so that we can find the average expected value and the standard deviation. So in list 1, or if you want to use list 3, 4, list 5, 6, put this in one list and the probabilities in another list. And then find your expected value and your standard deviation, please. I don't know what you're talking about. That's not weird at all. Jillian's going to put up the mean, variance, and standard deviation. Do you have a question, Monica, or just no? Okay. Thank you, ma'am. All right, so expected value, 6.85, which, like you guys, well, quite a few of you, 1, 2, 3, 4 of the groups predicted 6.85 because we can add our means together. So the expected value of t came from the expected value of x plus the expected value of y. Oops, forgot my parenthesis. Or mean of x plus mean of y. We can add our means, our expected values together. Now, Nolan's group said 2.073, but that was for standard deviation. And this is our variance. Now the variance we didn't focus on, but the variance for Pete's Jeep Tours was 1.1875. The variance for Aaron was 0.89. What do you guys notice about the variance of T? What happens if I add those together? I get that one, right? If I take 1.1875 and I add 0.89, may not be exactly the same because we have some rounding. 1.1875 plus 0.89, we get 2.0775. So just about the same, right? 2.07. So we can add variances. The variance of T came from taking the variance of X plus the variance of Y. I'm gonna flip back for a second to the previous page. If we took the standard deviation of P plus the standard deviation of Aaron, that's where you got this number, correct? We get the 2.0327. That is not the standard deviation that the calculator gave us. The calculator gives us about 1.44, which comes from the the square root of the variance. Because remember, standard deviation is the square root of variance. So to find the standard deviation of T, we would take the square root, maybe if my pen will work, of the variance of X. Seriously, it's a brand new pen. Why is it doing that? Variance of X plus the variance of Y. That idea is very important. On your test, I'm going to ask you to add or subtract random variables. And I'm going to ask you to give me the standard deviation of the combination. And the only way you can find the standard deviation is if you add the variances first, then square root. I promise it'll be on there. And unfortunately, some of you will forget until we're going over your test together, and I'll be like, how do you find standard deviation? You go, you square it, add them together, and square root it. Every year. I promise. It's on there. It's an important idea, but we'll forget it. All right, so down below, we have some summary again. Pete had an expected value of 3.75. Aaron had an expected value of 3.1. So together we have 6.85 passengers per trip. This can be generalized very similar to the way we wrote it up there. If we have two random variables, x and y, and t is defined as x plus y, the expected value of t comes from adding the means together, the mean of x plus the mean of y. You could also add more than two random variables together. So if I asked you to find, let's say, f equals x plus y plus z, you would just add the mean of x plus the mean of y plus the mean of z. When we have two independent random variables being added together, their variances can be added together. The standard deviations do not get added together. So again, if t is defined as x plus y, we can find the variance of t by adding the variance of x plus the variance y. And once we have the variance of t, we can square root it to find the standard deviation. We can only add the variances if the two random variables are independent. And no matter what, you can never, ever, ever just add standard deviations. That's the quickest way to get the answer wrong. Now, I won't always ask you to add variables. I can also ask you to subtract them. Rather than have you go through a whole nother example, I just took the same type of summarization. If we're subtracting, so if we have x and y are two random variables, and we want to find the difference, so we define d as x minus y, then our expected value of d comes from the mean of x minus the mean of y. When you're subtracting, order is important. X minus y is not the same thing as y minus x. Now here's the weird part. If we're subtracting two variables, we still add their variances. So the variance of d comes from the variance of x plus the variance of y. So no matter what, whether I'm asking you to add variables, subtract them, you always add your variances. And then the standard deviation of the difference would come from the square root of the variance. Always add variances. Now, down below is the exit task, but we're going to do it together because it is a difference problem, so it's different than the previous one. So this way we can see a difference. One together. Everybody okay if I move up the paper? All right, so on the left, we have the random variable x is defined as the number of cars sold for Mr. Wilcox in January. He could have sold 0, 1, 2, or 3 cars. Probability of selling 0 cars, 0.3, 0.4 for 1 car, 0.2 for 2, and 0.1 for 3 cars. Then we have y is the number of cars that Mr. Wilcox sells in February. He either sells 3 or 4 cars only in February. He's really good at his job in February. Probability of selling 3 cars, 0.6. Probability of selling 4 cars, 0.4. We are going to assume x and y are independent. Like I said, this time we're going to look at the difference. So we're going to define D as the difference in the number of cars sold between January and February. Now with subtraction, order matters. Difference between January and February, so we're going to do x minus D. I said x minus D. X minus y. Sorry. D is x minus y. So we're going to make our probability distribution. It might be helpful, you don't have to, but it might be helpful to add an extra row up above where you actually do x minus y. So you make sure you hit all the combinations. So in January, X, Mr. Wilcox could have sold 0 cars, and then he could have sold 3 in February. So the first combination is 0 minus 3. He could have sold 0 cars in January and 4 in February. So then we have 0 minus 4. If he sold 1 car in January and 3 in February, or 1 in January and 4 in February. Then we have 2 cars sold in January, 3 in February, 2 in January, and 4 in February. And then the last possibility for January is 3 minus 3 in February and 3 minus 4 for the last one. Like I said, that row is not necessary, but it kind of helps us make sure we get all the different possible combinations. So the value of D, 0 minus 3 is negative 3, 0 minus 4, negative 4, 1 minus 3 is negative 2, 1 minus 4, negative 3, 2 minus 3, negative 1, 2 minus 4, negative 2, 3 minus 3 is 0, and 3 minus 4 is negative 1. Because we're told that x and y are independent, to find the probabilities, we're going to multiply. So for this value of D, it came from 0 cars in January and 3 cars in February. So I'm going to do 0.3 times 0.6, which gives me 0.18. Here, that was 0 in January with 4 in February. So I'm going to take 0.3 times 0.4, which is going to give us 0.12. Oh, okay. Hi. Then we're going to move over to 1 car in January, so 0.4, and we're going to multiply that by the 3 cars in February, which is 0.6. 0.4 times 0.6, 0.24. You guys got the hold of how to find the probabilities now? Okay, so I want you to fill in the last 5 for me, please. That's okay, it's easy to miss. I'm the only one on this. Yes, they are. Have you seen the picnic table he built us?
I saw some pictures.
Yeah. That's his new hobby. I made him when we had our last kid, and our youngest is born in March, so I had my maternity leave through the end of the school year, and then he took paternity in the fall, and I said, I don't want you coaching me too, because I don't want to work all day, come home, and I need to be in your disappear. So I said, you have to take a break from soccer too, and that's what he filled it with. Was he found a new hobby, and he became a great woodworker.
Oh, I was like, what are you doing?
Don't you think I should wear that?
No, I think it looks better on her.
I've seen like the
Yeah, he is. Yeah. No,
All right, DJ's gonna fill in the rest of the table and do the bottom 3 problems for you.
And those were at lunch, and we literally like hopped over tables, like jumped on the table.
Sorry. Mine's slightly different.
Did you want me to put
We agree with that one. Go ahead and start filling it out. I'll just double check I didn't make a mistake, because I do that.
And then there were like, in one hallway, there was like 3 hallways on each floor. And in the front hallway, some of the lockers were like dented from the kids sleeping against them.
Dude, one day at my middle school, there was, I don't know what it was, it was like Friday the 13th, and everyone was like going around looking at us, there was like empty files. So people were like circling like that whole week, just like yelling up. And then there was like 4 fights, and all the teachers were like,
Oh, sorry.
and then like they told everyone to go inside, because there's like a huge fight going on.
I did do something wrong. Let's see, 0.18. Oh, that's just like, what is going on? My numbers were way
And
off.
there's like a bunch of kids like running inside also to like see another one.
Negative 2.3. Yeah, 1.06.
Apocalypse was happening, or like someone was coming to our schools.
So that one?
I'm assuming it's just we rounded. I use this and then you round it probably.
Okay, so these ones?
No, the 1.13 we agree on.
Like school got like they sent everybody home early and
Is that 5 or an 8? Not 9.
wow.
Killing me, DJ.
there was so much blood on the floor. Just some like a tunnel. And we couldn't go out through the main doors.
That's crazy. Yeah, like English is there.
Yeah, this one's kind of bad.
There's always always some petty shit as well, I feel like.
Yeah, probably.
It happens so often where you literally just be walking to class, everything will be fine, and then suddenly 2 kids will fight.
Yeah, it's just a rounding difference.
Good.
Thanks, DJ. All right, so 2 things. 1, you could show your work like DJ did. So DJ found the mean and no, you wrote down the variance for these, right? So DJ had the mean and the variance for both of these probability distributions. And that's where they got 1.1 minus 3.4, negative 2.3. 0.94 squared plus 0.489 squared, which gave you 1.128. I rounded to 1.13. Then when you square root, you get about 1.06. Or you could have typed the value of D and the probability into 2 lists and then had the calculator do all that work for you. Negative 2.3, standard deviation 1.063. Notice when you have the calculator do the work, it doesn't give you the variance. So if you had the calculator do the work to find the variance, you would take your standard deviation and square it. homework is that one, since I haven't given you your sheet yet. It is only the odds though. 37, 39, 41, 43, 45.